Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of inverse trigonometric functions. Well, in the previous class we have understood the existence of inverse trigonometric function. When do we say that inverse of a function exists? Only if it is both 1 1 and on 2. So if it is not 1 1, then you cannot find the inverse, and in the same way if it is not on 2 also it is not bijective, therefore you cannot find the inverse. So all these trigonometric functions are not 1 1 and on 2, therefore we restrict the domain of the inverse trigonometric functions, and then hence we define the inverse of them. See, what is the principal value branch of sine inverse? It is between minus 90 to 90, correct? So this is closed interval minus 90 to 90. Okay, anyway, now here I have listed the domain and the range of the inverse functions. If theta is equal to sine inverse x, the x values are called the domain values, correct? Okay, and okay, so if you want this in the right perspective, okay, so get this in the right perspective. If y is equal to f of x, then these values are domain values and these are the range values, correct? Okay, so for example, if you have y is equal to f of x is equal to x square, alright, so you write f of 0 is equal to 0, f of 1 is equal to 1, f of 2 is equal to 4, f of 3 is equal to 9, and so on. So these are the domain values, right? These are the domain values, and these are the range values. Okay, so 0, 1, 4, 9 and all that. So if you are talking about the whole numbers or integers, then you have only those values in the range. So why I am telling you this is so that you understand this x and the meaning of theta. All right, so these values are range. The value of sine inverse x is theta, the value of x is domain. So what values x can take? Any value between minus 1 to 1, and minus 1 and 1 are included. Okay, the range is the principal value branch. Okay, so this is also included, so minus 90 to 90. So you can write this as a closed interval minus 90 to 90, correct? Similarly, you can write this as closed interval minus 1 comma 1. Okay, so that is another way of writing it. I thought this would be better for you. Okay, so you will get a better understanding here. Well, next, cos inverse, I have explained this already. So minus 1 to 1 closed interval is the domain, and 0 to theta closed interval, 0 to theta 0 to pi, I'm sorry. So closed interval 0 to pi is the range, and tan inverse x, all the real numbers are domain. You can take any real number, okay, and the range is minus 90 to 90. Okay, so when you write this, you don't use closed interval because the end values are, boundary values are not included, therefore I write open interval. Well, coming to this point, so x is, for cosec inverse, x is greater than or equal to 1, or x is less than or equal to minus 1. Alright, and what is the range? The range is between minus 90 to 90, where theta is not equal to 0. We'll continue to solve some interesting examples such as these. Okay, so the first one for this particular class, cos inverse x minus sine inverse x is equal to 0, then the value of x is. So the options are half, 1 by root 2, 1 and none of these. Let us solve it. It's a very simple question. Okay, so cos inverse of x minus sine inverse of x is equal to 0. See, I have a property. What is the property? Sine inverse x plus cos inverse x is equal to pi by 2. Okay, for x belonging to minus 1 to 1. Well, now I have to replace either cos inverse or sine inverse, anyone. So what I'll do, I'll replace cos inverse. So what is cos inverse? Pi by 2 minus sine inverse. Okay, so that's what I will substitute in place of cos inverse. So that is pi by 2 minus sine inverse, and this sine inverse I will take as it is. Well, now this is minus sine inverse, therefore pi by 2 minus 2 times sine inverse x. Now this will be 2 sine inverse x will be positive, that is equal to pi by 2. Well, that brings us to sine inverse x. This 2 will be divided here, so 2 into 2, that will be 4. So pi by 4, hence the value of x. So what is the value of x? For what angle, for what value do I get pi by 4 angle? So for the value of 1 by root 2. Okay, so for the angle pi by 4, the value is 1 by root 2 for sine. So 1 by root 2 is the right option here. I hope that is cut and clear there. Let's move on quickly to the next question. Alright, the question is sine inverse of 1 minus x minus 2 sine inverse x is equal to pi by 2, then the value of x. Alright, your options are 0, half, 2 solutions of x, okay, 1, half, 0 or only half. These are the options that we have. Let's start. Let me take the given expression, sine inverse of 1 minus x minus 2 sine inverse x is equal to pi by 2. Now 2 sine inverse x is equal to pi by 2 minus this, I'll take to the right hand side, so that will be sine inverse of 1 minus x. Okay, next once again I'm using the same property. Okay, it's already there. So pi by 2 minus sine inverse x is cos inverse x. So in this place I will write cos inverse x. So what is x? In place of x I have 1 minus x, and this is minus 2 sine inverse x. Well, next take cos both sides. So if I take cos both sides, this will be cos of minus 2 sine inverse x, that will be cos of cos inverse will be 1 minus x for the specified values of x. Alright, next what? Well, next cos of minus. What is cos of minus x? Cos x. So I can write this as cos of 2 sine inverse x. Why? Because cos of minus x is equal to cos x. Trigonometric formula. Okay, cos of minus x. So this is cos of minus is plus cos. Well, now cos 2x formula. So what is cos 2x formula? So cos 2x, I have 4 different formulas, but the formula I will use is this 1 minus 2 sine square x. Why? Because I have sine inverse, therefore I am using that formula. So cos 2x So in place of x, I have sine inverse. In place of x, I have sine inverse x. Therefore, here also I should write sine inverse. So it will be sine of sine inverse. That's why I am choosing that formula. Otherwise, I have 2 cos square x minus 1, cos square x minus sine square x, or the next formula is 1 minus tan square divided by 1 plus tan square. Okay, all those formulas I am not using here. Now, this is 1 minus 2 sine square sine inverse. I hope you understood. Cos 2x, 1 minus 2 sine square x. In place of x, I have sine inverse x, and there we don't have to change anything. Okay. Well, now what is sine square? Sine into sine, or you can write, see, understand this, sine square x means sin x into sin x. So sin x into sin x is sin x whole square, right? So therefore, I will rewrite this. So how we can rewrite? See, 1 minus 2 sine of sine inverse x whole square, that is equal to 1 minus x. Okay. So sine square I have written sine of sine inverse whole square. Now, what is sine of sine inverse x? That is only x for all the values between minus 1 and 1. Okay. So 1 minus 2 x square, because sine of sine inverse x is x and that square is there, that is equal to 1 minus x, correct? So now we can cancel 1 both sides. So minus 2x square I will take to the other side. So it becomes 2x square minus x, that is equal to 0. Well, now you can take x common. So if you take x common, you will get 2x minus 1 is equal to 0. So either x is equal to 0 or 2x minus 1 is equal to 0. 2x is equal to 1. X is equal to half. Okay, so you got 0 and half. So you think first option is the answer, right? No. Here there is a catch. Okay, you have to verify whether those values satisfy the given equation or not. If it satisfies, then fine, A is the answer. Otherwise, not. Maybe C is the answer or D is the answer. Alright. So you have to be careful here. Just because you got these two values, fine, so A is the answer, done. No, you will not get any marks for this because A is not the answer. Why? I will tell you. See, when you put x is equal to half here, what will happen? So 1 minus half, that is half. So sine inverse half. What is sine inverse half? Minus 2 sine inverse, I have to put half. Correct. So sine inverse half minus 2 sine inverse half, that is minus sine inverse half. Alright. So what is minus sine? I mean, what is sine inverse half? Sine inverse half is pi by 6. So the answer is minus pi by 6 here. Minus pi by 6 here. So are you getting pi by 2? No, it does not. It does not satisfy. It does not satisfy. When it will satisfy? No, only when x is 0. If x is 0, sine inverse 1 is 90, sine inverse 0 is 0, so answer will be 90. So only this value will satisfy. This value does not satisfy. Okay, so only x is equal to 0. Therefore, option C is the answer, not A. So please understand this. Just because when you solve, you have got two values, don't jump into conclusion that A is the answer. Okay, you have to verify and check if the values satisfy the given equation or not. Okay, in the first case it does not satisfy, but in the second case it satisfies. So x is equal to 0 is the answer. Well, move on to the next question. Well, the next question, question number 4. The numerical value of tan of 2 tan inverse 1 by 5 minus pi by 4. Okay. So, what I will do is, I will just find the value of this, okay, or I will take it as theta. Then let us look at the expression, how it goes. Alright. So, what I am doing, let tan inverse of 1 by 5, I will take it as theta. Okay. So, if I take it as theta, then what is tan theta? Tan theta will be 1 by 5. Is it not? Now, look at the expression that I am getting here. So, tan of 2, in place of tan inverse 1 by 5, I am going to write theta minus pi by 4, correct? Now, this is like tan x minus y type. So, what is tan x minus y? That is tan x minus tan y. So, tan y means tan pi by 4 divided by 1 plus tan x minus tan y into tan y. Correct. Okay. So, understand, tan x minus y is tan x minus tan y, 1 plus tan x tan y. So, that is the formula from the trigonometry. Well, so I will replace this tan pi by 4. What is tan 45? Tan 45 is 1. So, therefore, I will write 1 here. So, this will be tan 2 theta minus 1 divided by 1 plus tan 2 theta into 1. Okay. So, now what I need is, I need tan 2 theta answer. So, what is tan 2 theta formula? Tan 2 theta is 2 tan theta divided by 1 minus tan square theta, and see, that is tan 2 theta minus 1 divided by 1 plus again tan 2 theta. So, that is 2 tan theta divided by 1 minus tan square theta, correct? So, I hope that is understood. It is just tan x minus y formula and tan 2 theta formula. Well, now let us substitute tan theta. You know tan theta 1 by 5. So, put it here 1 by 5, 1 by 5, 1 by 5 and 1 by 5. That will be the answer of this particular expression, Well, let us continue. So, this is 2 into 1 by 5, okay. So, divided by 1 minus 1 by 5 square, that means 1 by 25. So, here anyway, so minus 1 divided by, you have 1 plus here 2 into 1 by 5 divided by 1 minus 1 by 25. So, this is what I have to simplify, okay. So, this is 2 by 5 divided by 25 is LCM, 25 minus 1, 24 by 25 minus 1 whole divided by 1 plus. So, this is 2 by 5 divided by 25 minus 1, 24 by 25. Okay. So, let me continue here. Well, now see, what I will do is, I will just take the reciprocal here, or this is 5 ones are 5 5s are 2 ones are 2 12s are. So, this goes up 5 by 12 you will get. So, that is 5 by 12 minus 1 divided by 1 plus, once again the same. So, 5 by 12. Well, now you can take LCM. So, 5 minus 12 divided by 12 whole divided by 12 plus 5 divided by 12. So whereas 12 gets cancelled, and then 5 minus 12 is minus 7, divided by 12 plus 5 is 17, and that is the option B. So minus 7 by 17 is the answer of this. So when you have these fractions, be careful. Okay, so be careful, do it with care. Well, let's move on to the next question here. See, this question is about range, but there's a catch. If you just go with the range, you will not get the right answer. So you have to think about domain as well, So we'll see how. So let us understand the question first. If range of the expression sine inverse x plus cos inverse x plus tan inverse x is m comma n. Okay, so that's the range of this expression. You just have to add these numbers. Okay, so you have to find m plus n, that's it. The lowest point and the highest point, lowest value and the highest value have to be added to get that m plus n value. Well, now first let me start with the given expression. The given expression is sine inverse x plus cos inverse x plus tan inverse x, right? Now what is sine inverse x plus cos inverse x? Pi by 2 exactly. So pi by 2 plus tan inverse x. Okay, now you have to understand the range of this expression. So you may say tan inverse x is between minus 90 to 90, right? So you may say it is between minus 90 to 90. So when you add, you will get 0 and pi. So you may say that 0 comma pi, so 0 plus pi is pi. A is the answer. No, that's not the case here. See, why that's not the case? You cannot, see, we are talking about the value of tan inverse x based on the value of x. The output value of tan inverse x will be obtained based on the input value that you put in place of x, correct? So input is not, see, what is the input for tan inverse? What is the domain for tan inverse? The domain for tan inverse is all real numbers. So now question is, can you put all the real numbers here? This is also x, right? The given expression is this. So can you put all the values from the real numbers in place of these x? Here you can. But can you put it here? No. Can you put it here? No. Because the domain of this particular expression is, so what is the domain? It is minus 1 comma 1. Is it not? So that is minus 1 comma 1. You are not allowed to put all the real numbers there. You are allowed to put the values only between minus 1 and 1. Hence, when you put the value in this place of x, also you have a restriction. You cannot put all the real numbers. You have to put the values between minus 1 and 1 only. So hence, now let us understand, this is pi by 2 plus, now when you put minus 1 to 1 here in place of x, the domain is for x, okay. So put minus 1 here. What is tan inverse of minus 1? That is minus pi by 4. And what is tan inverse of 1? So tan inverse of 1 is pi by 4. So you are allowed to put the values only between minus pi by 4 and not these values. You cannot put minus 90 to 90. You can put only till minus 45 and up to plus 45. You cannot go beyond 45 till 90. You cannot, because of this. Okay. Well, so now what is pi by 2 minus pi by 4? 90 minus 45. That is 45, right? So therefore this is 45, and pi by 2 plus 90 plus 45, 135. So that is 3 pi by 4. See, this is 2 pi by 4. 2 times 45, 90, correct? 2 pi by 4 plus pi by 4, 3 pi by 4. So this is 3 pi by 4, and that is m comma n, that is the range. Now you got to add these. So 3 pi by 4 plus pi by 4 is 4 pi by 4. Alright. So when you have 4 pi by 4, when you have 4 pi by 4, what is the answer? Pi is the answer. Well, so 45 plus 135, that is 180. So 180 is the answer. Well, you are getting the same answer when you go for this or that. So now, well, you may say, okay, let me do this, but that's the wrong way. For this problem you may get both same, but there are some problems where if you go in this way, you will not get the same answer. Coincidentally, by chance, by luck, you are getting the same here, only for this problem. Okay, not always. So learn the right method. Don't just think that, well, we can get the answer in any way we want. No, you cannot. Okay, so learn the right method, understand the original expression, and then only apply the range. Okay, so we have to think about the domain here to get the range. Alright, so for this domain, for this expression, the domain is only between minus 1 and 1. Hence, put that minus 1 and 1, you get the range of tan inverse, and this is pi by 2. Okay, so just add them, you will get the range of the total expression. Well, so this is about getting the range using the domain. Moving on to the next question. Let's continue with the question number 6. Let us just understand the question first. This looks very complicated. Okay, looks like a JEE advanced problem, but it's not a very simple problem. Okay, you can expect this in CET as well. Let me explain this question to you. If sine inverse of this infinite series, okay, so dot dot dot, 3 dot represents infinite elements there. Okay, so x minus x square by 2 plus x cube by 4, and here you have cos inverse of x square minus x to the power 4 by 2 plus x to the power 6 by 4 is equal to pi by 2. Remember this expression, okay, this property. So the property is sine inverse x plus cos inverse x is equal to pi by 2. Right, students? Okay, you know that property. Okay, so now look at this. You have got the answer pi by 2. I mean, they have given the answer should be pi by 2. So when it will be pi by 2? Only if these expressions are equal. These values of x must be equal. Alright. So first expression that you have, x minus x square by 2 plus x cube by 4 minus so on. Okay, so this is infinite series, and that should be equal to x square minus x power 4, and this is x to the power 6 by 4 minus, okay, so on. Now, is it AP or GP? Okay, so this is geometric progression, and why it is geometric progression, I'll tell you. You have a common ratio. I'll tell you what is the common ratio here. See, the first term A is x, and the common ratio, how do you get? Second term divided by the first. So minus x square by 2 divided by x. So this is x by 1. So you can write it as minus x square by 2 into 1 by x, correct? So you can cancel this. Minus x by 2 is the common ratio. Now check with this. Subtract x cube by x square, you will get x. 4 by 2, you will get 2, correct? Okay, so this is a infinite GP. Now what is the formula to find sum of infinite GP? What is S infinity formula? So S infinity formula is A by 1 minus R. So this is the formula to find S infinity of this. So this expression becomes A, that is x divided by 1 minus what is R? R is minus x by 2. So eventually that will become plus, but let it be like that. We'll come back to it. Now what is A here? A is x square, and what is R? Okay, common ratio. R is minus x to the power 4 divided by 2 divided by x square. So x square and okay, x to the power 4. So that is like minus x to the power 4 divided by 2, and is x square by 1. So it is 1 by x square. So x square and this can be cancelled, only x square will remain. So minus x square by 2 is the common ratio, and once again the formula is same. So what is S infinity for this? S infinity is A divided by 1 minus R. So R is minus x square by 2. Well, so we have arrived at this stage. Now it is very easy to find the value of x. Alright, so that's a simple thing. We'll just use those fractions and simplify. So what you can do is you have x divided by 1 plus x by 2, that is equal to x square divided by 1 plus x square by 2. Well, so this is x, so this is 1 by this will be 2 plus x. All right, well, you can cancel this 1 also when you cross multiply. Anyway, we'll take the LCM here. So this is 2 plus x whole divided by 2, and that is equal to here x and here it is 2 plus x square divided by 2. So you can cancel out this 2 also. So this will be, when you cross multiply, 2x plus x square, that is equal to cross multiply here. So 2 plus x square, correct? Okay, so once again you can cancel x square, that means 2x is equal to 2, x is equal to 2 by 2, which is 1. Okay, so 1, therefore 1 is the right answer for this. So this question is based on the property of inverse trigonometry, and what property is that? Sine inverse of x plus cos inverse of x is equal to pi by 2. So if you have these quantities equal, then only you will get pi by 2, otherwise you will not. Okay, so you have got pi by 2 answer there. That means the quantities are equal and it is infinite GP. Use the infinite GP formula, equate them, simplify the fractions, you get the answer of x. So that's it for today's class. We have solved a few examples of inverse trigonometry. We will continue to solve these examples. So thank you very much for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.